Hello again, Mr. Wakefield here. We have a couple more videos to go here in Math 51. Uh, First one's called the interest problems, and then the very last video is going to be called work problems. Uh, Once again, boxes are going to be involved. All right. In the interest problems, we're going to have the 3 rows again. But in the work problems, we'll go back to a different format that we did with the motion problems. Different formula, but the same number of boxes we had in the motion problems. So, but the box format, however, is kind of what we're working on here in these last 2 videos, along with the previous 2 videos, previous 3 videos that we've done. Going back to the motion problems. And with these box problems, we always have a formula that involves 3 different parts. In this case, the 3 different parts are principal, rate, and interest. Okay, let's talk about that. Principal is when you invest something at the bank, okay, or maybe even if you borrow something, although in this worksheet, we're just going to focus on investing instead of borrowing. So this is investing. Let's say, for example, you invest $1,000. Okay. In fact, I'll write that down. And let's say that the banker says to you, okay, I'll give you, I'll put it into an account for you where it will make 3% simple interest. Okay. Because this is actually a simple interest formula. There are different types of interest formulas that they have at the bank. But this one's called simple interest. That's what we're going to do. So if it's 3%, then that means that, like we've talked about in the past, when you put a percentage inside of an equation, you need to convert that by doing 3 divided by 100 into your calculator. If you do that, you'll get 0.03. Okay, so there's your investment. There's your percentage interest rate converted to a decimal so that you can put it into the equation. And then we multiply those things together in order to get the actual interest that you make. Okay, and this is going to be the annual interest. Just the interest in 1 year. But that's all that we're going to be focusing on here in this worksheet, so that'll be fine. So multiplying those together in your calculator, you'll get 30. So that means that you'll make $30 interest in 1 year, which means that you would have a total of $1,030 in your bank account after 1 year because the 1,000 was already in there, and then the bank added $30 to that. Okay, so that's how this formula works. But the reason why we need the boxes again, here's just a sample problem right here. The reason why we need the boxes is because we're going to be looking at 2 different interest accounts together. And the reason why we're going to be looking at them together is because we're going to look at how much total interest the 2 accounts made together. And so that's why you need this 3rd row right here. You need the 3rd row to be the together row, looking at the 2 accounts together. And then the first 2 rows are always the 2 accounts that you're talking about. In this problem, there's a 4% account and there's a 6% account, and so that's what this was here. I'm not going to get into this problem too heavily. You can read this on your own time if you like. You don't have to. But this problem is very similar to the 2 problems we're actually going to do, and so we really don't need to go over this also, but you're welcome to read it just as an additional practice, okay? Let's jump right into it here, though. But again, we're looking at 2 different interest accounts together. All right. First one. With income earned by selling the rights to his life story, an actor invests some of his money at 3% and $30,000 more than twice as much at 4%. Okay, so you can see there's 2 different accounts going on here. He's got a 3% account and he's got a 4% account. The total annual interest earned from the investments is $5,600. Remember, we said before that the word total is usually referring to when you add up things, right? Well, there's 2 investments here, so they're talking about adding up the total interest from both accounts here. And then the is, of course, means equal. We'll get into all that coming up. How much is invested at each rate? Okay, so the first thing we want to do is, like we always do with word problems, identify what we're trying to find, attach a variable to it. Okay, it says here in the last sentence, how much is invested at each rate? How many rates do we have? We've got 2 rates. Remember, rates are the percentages in these problems. Okay. By the way, speaking of percentages, I want to clear something up real quick before I go on here. Notice in the interest problems we got some percentages, but we've also got some money that they talk about, right? Well, we've had problems in the previous couple of videos where sometimes we have percentages and sometimes we had money. So that can be kind of confusing, right? As far as keeping all this organized and knowing which formula to use at what time. Well, because we've had other problems that had money in it and had percentages in it, let me just encourage you that when you're on a test and you're trying to figure out what formula to do, please remember that when they talk about interest, then you're going to do that PRI formula that I just talked about. Okay, so whenever they talk about interest, just remember that you're going to use this. You're not going to use one of those two formulas from the previous two videos that we did. The mixture problem videos that we did. No, you're going to do this. Okay, and so that'll help you remember, or that'll help you avoid getting confused rather between those things. All right, so PRI is what you use when they talk about interest. Right, and then we talked about when we're supposed to do those mixture formulas and at what time. Okay, we talked about it in the previous video, so continue to follow those rules from that video as well. But PRI for investment and also for interest. But if you see that word interest, okay, they're talking about interest from an investment. You're going to do PRI. All right, so how much is invested in each rate? There's two rates. When they talk about interest, when we're in an interest problem, the rate is the percentage. So we've got two percentages, therefore we have two rates. And so we're going to have two questions here, therefore, since it says each rate. All right, so they want to know, they said how much is invested, so they want to know the investments, right? Okay. So there's two different investments they want to know. I'll call one of them X, and I'll call one of them Y, but let's be specific here so we don't get confused, as I've mentioned before. That's important to be specific when you identify what you're trying to find. Let's make this one the 3% investment, and let's make this one the 4%. Okay, but you're going to, in these interest problems, you're going to have two different types of investment, and you can tell them apart based on their interest rates. And that's why I wrote down the interest rates next to it here. Okay, step 3 is what? Step 3 is when we do that box thing, and just like in the sample problem up above here on the worksheet, you're going to want to have 3 rows and 3 columns. 3 columns because we have a 3-part formula, P, R, and I, like that. And then 3 rows because, again, we have 2 types of investments, the 3% investment, the 4% investment, and then we're going to look at those 2 investments together down here in the last row. And like always, let's start out by filling in our first column and then working our way over. Okay. Now, principal is the same thing as investment. It's just another word for investment here. And so what they're asking for in this first box is the principal at 3%. The principal at 3%, and so that's X, isn't it? Same thing as investment at 3%. So we put the X there. Likewise, we put the Y there because that's a principal at 4%, as it says right here, investment at 4%, same thing. Now, do we know the total investment altogether? No, we do not know that. Okay, they don't tell us that. We also don't have a variable for it because we already used up our variables on these 2 individual investments. Okay, we don't have a separate variable for the total investment of both of the investments together. And so as I told you before, if you do not know what a box is equal to and you don't have a variable for it, okay, unless it's this middle box on the bottom, which we said you can keep that blank when you have 3 rows, all right, just the 3 row problems I'm talking about, as we talked about in previous videos here for the mixture problems. If this box, if you don't know what it is, and you don't have a variable for it, we leave that blank, and that's exactly what's going to happen here. I'll explain that here again in just a second. But all the other boxes, if you don't know what it's equal to and you don't have a variable for it, you try to fill it in some other way. And as we learned with the mixture problems, it is still going to be true here. As we learned with the mixture problems, you can add down on the first column. You can't add down on the second column, but you can add down on the first and third columns. All right. These interest problems are no exception. They're just like the mixture problems in that regard. So I'm going to say x plus y. Remember, these are not like terms, so just say x plus y. Don't combine them. The rates are what? Again, we got to convert them to decimals, just like we did in the first mixture video that we did when we had those percentage problems. Same thing here. 3 divided by 100 and 4 divided by 100. Since we're going to be putting these things into equations eventually, they need to be converted to decimals. And then when we get to the last column, and we saw this on some of those mixture problems, this last box down here in the bottom, we can fill that in. Okay, again, if you know what one of these boxes is equal to, you got to fill that in. Don't multiply across. At least not yet, okay, until you check to see if you can fill any of these in. And if you can, then you got to put that in there. Notice that this 5,600 number says the total interest. Okay, notice that this box right here means what? It means the interest altogether. Interest together, that's the total interest, isn't it, of the two investments together. And so that's why the 5,600 goes there. It does not go... Talking about the 5,600, it does not go in either one of these two boxes because this box is the interest just from the 3% account only, and then this one is just from the 4% account. The 5,600 was the total of both of them together. Okay. We don't know what these two boxes are. Okay, we don't have a variable for it. We already used it up on investments. This is interest, not investments. So like we've seen so many times in the past when we do these box problems, if you don't know what a box is equal to and you don't have a variable for it, but it's in the last column, you can use this formula to go across. So P times R equal to I means X times 0.03, that's 0.03X. Y times 0.04, 0.04Y. And there you go, you filled in the box. Again, this one cannot be filled in because we don't have a rate for the two accounts together. We just have individual rates for each individual account, but not a single rate for both of them together. We also don't have a variable for this box. And so, like I said before, in the third row in the second column, that one can be left blank. But all the other boxes need to be filled in somehow. So as we talked about in the mixture problems as well, we can add down and we can multiply across to find potential equations. Well, I can't multiply across on these two because that's just going to be an identity. X times 0.03, 0.03x is just the same two things. I can't, same thing here with this, same thing, that's going to be an identity. I can't add down here because it would be x plus y equal to x plus y. Again, two things that are identical. However, I can add down on this one. That's not going to be an identity. That's two different looking things there that aren't identical to each other in any kind of way, but they are supposed to be equal to each other nonetheless because we know that we can add down on what? The first and the third column, right? And so we have an equation. As we saw at the end of this last video, though, sometimes when you're doing the box problems, you have to go back to the problem to find a second equation. This is no exception. Okay. The reason why we need a second equation is because why? Because we have two variables, right? So we need to go back to the second equation. I'm sorry, go back to the problem to find the second equation. And I want to talk about this right here. See where it says at 4%? Okay. Let me show you a simpler example here for just a moment. It says, I'm going to look at a much simpler example here. Let's say that I invested $1,000 at 4%. Notice the key words there, at 4%. When they say the word at and then they give you a percentage, okay, and they put a money amount just before that, you can basically rewrite it like this, okay? 1,000 at 4% is the same thing as 1,000 is equal to the 4% investment. Okay, so if I said I invested $2,000 at 3%, then that would mean 2,000 is equal to the 3% investment. But the reason why I rewrite it is because now I have an equal sign right here, which means I can create an equation. Okay, so in the same way, you guys, in the same way, I can take this sentence right here, and since it says at 4%, I can then rewrite that as is equal to the 4% investment. Looks like an equation is developing here. Okay. Now, what about what came before that, though? It says 30,000 more than twice as much. Okay. So what that means is that 30,000 more than twice as much is equal to the 4% investment. But here's the problem, though. What does the word much mean? Twice as much as what? Well, let's talk about that for a moment, and then we'll put it all together. Another simple example here, unrelated to this problem, but it'll help you understand the current problem, though. I have $10. Just pretending, of course. I have $10. You have twice as much. Twice as much as what? Well, when they say twice as much, you guys, aren't they referring to what they would just talked about just before that in the previous statement? If I say I have $10 and you have twice as much, aren't I just saying that you have twice as much as the $10? Twice as much as $10? Okay, which would be $20, of course. But that's the thing. The word much, when they say it like this, twice as much, they're referring to the amount of money that had just been mentioned in the previous statement, just before they said twice as much. And it's the same thing here. Okay, when they say 30,000 more than twice as much, they mean 30,000 more than twice as much as what they had been talking about just before that, which is when they mentioned the 3% account. Okay, and so let's put all that together now. My arrow got in the way there a little bit. Let me just move that over. There we go. So 30,000 more than, okay, and they're saying what? They're saying twice as much as the 3% account. Okay, but the 3% account is what? It is X. So it's 30,000 more than 2 times X, isn't it? 30,000 more than 2 times X. All right, you don't need to put the times there, but just emphasizing that. So 30,000 more than 2 times X is equal to the 4% investment. By the way, the 4% investment, that's Y, isn't it? The letter Y. So 30,000 more than 2X equals Y. Let's write that down. 30,000 more than means plus 2X is equal to Y. Now remember, you guys, we talked about in the past where, and we'll see this again coming up, when something is more than something else, you can use this formula. This is back in the 3.4 worksheet. But this current problem we're working on is slightly different than this. I want to make sure you understand that. Okay? This is when it's just strictly more than. Okay? When something is more than something else. This is different because it says more than twice as much. Slightly different than just saying more than only. Okay? And so if I say that I have 2,000 more than you, then you can use this formula. But if I say that I have 30,000 more than twice as much as you, then that's different. Then you have to do something different, and that's why I did what I did here, where I talked about the at 4%, and I talked about, what to do with the word much and all that kind of stuff. And so that's what you would do when they say twice as much at 4%. Okay, this is the approach you'd take. Let's go ahead and finish off this problem here. Now that I've got my 2 equations, and since one of the variables is already by itself, it'd probably be easiest to take this and use the substitution method. And since y is equal to this right here, I'm going to plug it into the other equation. I'll put the 38,000 plus 2x in the place of where the y is. All right, just like normal. And let's see what happens here. Then I solve that one variable equation I have left over. I distribute first, of course. And that would be 1,200. Just distributing here. plus, and then 0.04 times 2 is 0.08. Again, make sure you use your calculator carefully to figure that out. Then after I distribute, I combine like terms. 0.08 plus 0.03 is 0.11 on your calculator. Then I need to move over the 1200. Okay, and that gives me this right here. Like that. Okay, and then I divide out, and that gives me 40,000 in your calculator. If you put that in your calculator, 4,400 divided by that decimal. 40,000, but we still got to figure out the other variable. So I plugged the x into the 40, pardon me, I plugged the 40,000 into the x, I should say. Put it up here. 30,000 plus 2 times 40,000 is equal to x. I just got it from here. X is already by itself, and it's not on the other side either. No variable over here, so I just do order of operations. Multiply first, you get 80,000. Then you add it to the 30,000, and you get 110,000. So the final answer, I'll go ahead and put it down here. Okay, whenever you get two answers in a word problem, what two things do you need to do? First of all, you need to tell me what the numbers mean as far as the unit of measurement. Okay, 40,000 watt and 110,000 watt. Okay, is it grams? Is it miles? Is it feet? Is it ounces? No, it's none of that, right? It's an investment. Investment means money, right? And so how do they measure money in this problem? They measure it with dollars, right? Not cents, but dollars. Okay. In all the problems in this class anyway, we're not going to be dealing with currency from outside of the United States, and so we'll just be dealing with dollars and cents. Okay, so just look if you know that it's money that you're trying to find the measurement of, you know it's going to be either dollars or cents. So look for that in the problem. Okay. And then once you figure out how it's measured and you put that on there, I attach a dollar sign to say how it's measured. Okay, then you also have to what? You got to say which one's which. And again, you don't have to write some big thing. Just tell me the difference between these two things, okay, as far as what you were trying to find. Since the 40,000 was X and since the X was the investment at 3%, just write down 3% next to that. You don't need to say investment at 3%, all right? Just enough that I know the difference between the two things here. You don't have to get too detailed. Just like we've done on previous problems where we've had two things that we found, all right? Tell me which one is which. And there's your answer. We answered it. We found out how much was invested at each rate. Okay, we have one more problem to go. All right, it has some similarities but also some differences, and that's why we're doing it. Okay, we're not just going to repeat the same thing again, but there will definitely be some similarities here. On the second page here, and by the way, there is a third problem that we're going to skip. You can put the word skip right there. It's completely different from everything else. Well, it's significantly different anyway from everything else. You're not going to see this kind of problem in the homework either, so we can skip it. We're just going to look at number 2, all right, and then wrap up this video. Let me go ahead and read the problem here. Jeff made a total of 2 investments. He invested $2,000 more in the second one than he did in the first one. The first investment is at 2% interest. The second one's at 5%. How much did he invest at each rate? Isn't that the same question as the last problem? How much was invested at each rate? Okay, if he earned a total of $380 interest in 1 year. So again, the question is the same. We want to know the investment at each rate. Let me get that written down. What are the two rates? The two rates are 2% and 5%. Let's go ahead and use your variables there. I'll use X and Y. You can use any letters you like. All right. Step number 3. set up your boxes. As with any problem that has interest in it, we're going to use what? We're going to use PRI. So you got your 3 columns for that. PRI. And then you're going to have your 3 rows. What are the 3 rows for again? They are, the first 2 rows indicate the 2 investments. And then the last row is the, what we call the together row, where we look at the 2 investments together. All right, starting out with the first column like always, do we know the principal at 2%? We don't know it, but we have a variable for it, don't we? Again, investment at 2% is the same thing as principal at 2%. Same thing here, investment at 5%, that's the same thing as principal at 5%, and so the Y goes in this box here. Once again, we do not know the total investment or total principal altogether. We don't have a variable for it either because we already used up our variables on the individual investments. And so the only way I can fill in that last box is to add down, just like I mentioned in the last problem, x plus y. Once again, we do not know what this box is down here, which is the rate of the 2 investments together. Okay, we have individual interest rates, 0.02. and 0.05 when we convert them to decimals. Okay, be careful not to say 0.2, you guys. 0.2 would be 20% actually. So make sure that you divide by 100 in your calculator and you'll see that there's a 0 in between the 2 and the decimal point. Same thing here. All right, this is not 0.5. 0.5 would be 50%. No, this is 0.05 when it's 5%. But again, there is no interest rate for the 2 accounts together. So since there's no variable for this either, okay, we leave it blank. But again, all the other boxes should be filled in. Let's move into the last column. Last column says, just like in the last problem, we do know the total interest altogether, don't we? Okay, it says, just like in the last problem, it says total of $380 interest. So they tell you the total interest of both accounts together. All right, and the last problem was $5,600. Now it's $380. But we don't know the individual interest amounts. The interest at 2%, we don't know that. We don't know the interest at 5%. In other words, the amount of interest that was generated just by the 5% account, we don't know that either. So we don't know what these 2 boxes are equal to. We don't have variables for them either. The variables are for the principals over here. And so the only choice we have, again, like in the last problem, is to multiply across. And then just like in the last problem, this leads to only one equation, at least from the boxes anyway. It leads to only one equation. All right, all the other potential equations going across or going down on the first and third column, all of those options do not give you anything but identities except for the third column. And so I wrote down the third column. But again, this only gives me one equation. So since the boxes only give me one equation and everything else is an identity, okay, you need to go back to the problem and try to find a second equation. Well, notice here it says he invested $2,000 more in the second than he did in the first. That's, again, you see there that there's no equal sign in that sentence. Okay, it doesn't say is equal to or anything like that. Okay, so we can't do that, but what we did learn, and I'll go back to this again, if one quantity is strictly more than another quantity, okay, it's not more than twice as much like it was in the last problem. No. It's just 2,000 what? 2,000 more than. 2,000 more in the second than in the first. So it's just 2,000 more than. It's not 2,000 more than twice as much or something like that. It's just 2,000 more than. So because of that, we can use this guideline right here to help us. All right. When something is more than something else, you take the smaller of the 2 things being compared. What 2 things are being compared here? All right. When they say 2,000 more than, they're comparing the first investment and the second investment, aren't they? When they say that one is 2,000 more than the other. They're saying that the second one is 2,000 bigger than the first one. So they're comparing the 2 investments. All right. So you take the smaller of the 2 things being compared, you put it here. Okay. And so what is that? That's the first investment, right? The first investment was the 2% one. So since the 2% one is a smaller one, we put the x right here where the smaller quantity is. All right. And then what's the difference between the two things? 2,000, isn't it? Because it said 2,000 more than. So x plus 2,000 equals the larger of the two things that are being compared. And that would be the second investment. All right. Which, by the way, is the y here. Because they said the second investment was 5%. So the y is the second percent. There's the second investment, excuse me. Okay, so that means that we have what here? We have x plus 2,000 is equal to y. And so let's take that equation and let's move it over here. And we now have our two equations that we need. If you've got two variables, you're going to need two equations in your word problem, aren't you? Okay. Okay, so now that we've got our two equations, let's go ahead and solve. Again, since one of the variables is by itself, we take what it's equal to and plug it into the other equation like always. And so it's going to look like 0.02x plus 0.05, and then you replace the y with what it's equal to, x plus 2,000. And then you solve that equation. And again, it's looking very similar to the last problem here, isn't it? We have a linear equation here. So that means we need to distribute. Okay. 0.05 times 2,000 is going to be 100. And so then after that, after I distribute, I combine like terms. Like that. And then I need to get the two constant terms to the same side, opposite side of where the variable term was. So we get 280 on the right-hand side. We then divide out. What is 280 divided by 0.07 in your calculator? That's going to be 4,000. Now, we got to figure out the other variable now. And so I plug 4,000 into x right here. Okay, that same equation you always use when you're doing the substitution method, the one that you plug into the other equation. Okay, that's where you plug it. That's the easiest place to plug it into to figure out that last variable. And we end up with 4,000 plus 2,000 is 6,000. So our two answers are 4,000 and 6,000. Again, when you found two things in a word problem, say how they're measured first, and then tell me which one's which. Again, since it's investment, that means that it's money. Money is measured how in this problem? It's measured in dollars. You can see that right there. You're using dollars. It's not cents, it's dollars, right? So it's $4,000 and $6,000. But which one is the 4,000 and which one is the 6,000? Okay, the 4,000 was the X, and since that's the investment at 2%, you don't have to write out that whole thing there. Just say 2% for short. Okay, and I'll know that you're referring to the 2% investment. The 6%, the 5% is the 6,000 then, because the 6,000 was the Y, and the Y is the 5% investment. Okay, so that concludes our discussion on the interest problems. Again, remember, anytime they mention interest and investments and that kind of thing, you're going to use this formula here. Okay, and so this is the type of setup that you do right here, the one that we did in the last two problems, when you are what? When you are doing a problem where they talk about two different investments, okay, and they talk about when they have two investments and they give you the total interest of both of them together in 1 year, okay, because this formula is just for 1 year, as I mentioned earlier. And so when they mention total of a certain amount of money of interest in 1 year, that's why you've got to have that final third row right there, the together row, all right? but this is what we do in that situation. Okay. Now, before we conclude this video here on interest accounts, wanted to look at a few homework problems, because I'm going to assign 5 homework problems just on the interest problems. And in those 5 problems, 4 of them actually are slightly different than what we looked at here in the worksheet, but it's just very slight difference. And so it's not that we need to learn something brand new here. It's just a slight thing that I want to show you here. Notice in this first problem that I'm going to assign, number 25, Amir receives a $15,000 signing bonus upon accepting his new job, and he's going to invest that amount there in 2 different accounts, some of it at 6%, the rest at 7%. Okay, what's different about this problem compared to the ones we did is that they actually tell you the total principal altogether. Okay, they're saying that he invested a total of $15,000. It also says that he earned a total of $960 in interest. Okay, that's the total amount, because it says he earned a total of $960. So they mean both of the accounts together. So in this particular type of problem, you guys, what you would do is you would put the $15,000 here, and you'd put the $960 here still. Okay, but you're not going to have x plus y right here, because you actually know what that's equal to. So if you know the total principal or total investment altogether, you're going to put it there. And what that's going to create is it's going to create a situation where you can come up with 2 equations right out of the boxes here. Okay, you'll have x plus y equal to 15,000 right here, and then you'll have your normal equation that you would normally get over here. All right, just like the problems we've been doing. And so you don't need to go back to the problem, okay, in order to find out a second equation. All right, you'll be able to find one from the first column, and you'll be able to find another one from the third column. Not all the problems are like that in the homework, but 4 out of the 5 are. There is one problem which is very similar to this kind of thing here, like we talked about, where you get one equation from this column, and then the other one you got to go back into the words up at the top in order to find the second equation. So I just wanted to clear that up with you, okay? Yes, 4 out of the 5 problems will actually tell you the total investment altogether, and so you would put it in that first column at the bottom. Okay, so let me know if you have any questions about anything, as usual. So that'll do it for this video. Take care, you have a good day, and we'll see you back for the very last video on the work problems, as they're called.